Hello, everybody. Welcome to our webinar, the next from the CSRD expert series. In today's webinar, biometrics big impact from the Hive to CSRD. We will discover an innovative approach to sustainability with the help of the bees. And today, as our experts, we have Kamil Baj. Kamil Baj is the owner of Pszczolarium. And also we have Ben Poirot. And Ben, the stage is yours. So please start with our presentation.
Thank you so much.
Mam wyciszony, tak?
Państwo na razie włączają mikrofon.
Okay, so hello everyone. Thank you so much for joining today. So I'm Ben Poirot, the CEO of the research center Happy Lab in France. I'm also one of the partner of the EU project INSIGNIA, but I will talk about it later. I'm very happy to be here with Kamil, our partner, to share how bees can help us measure and protect the environment. This talk is about turning bees into powerful environmental sensors and create simple numbers of KPIs that company can use to report and act on biodiversity. That's why we call it biometrics big impact. So let's jump in. Let's start with a simple question. How can we protect nature if we cannot measure it? We know biodiversity is declining, unfortunately, and we all agree it needs protection. But the problem is that measurement is difficult. Without reliable data, it's hard to understand what's happening, to track progress, or to prove impact. Bees offer a solution. They work every day, covering large areas, and they bring back this incredible amount of environmental information. With science, we can use that information to create simple numbers that everyone can understand and act on, from science to company managers. Why is biodiversity measuring such a challenge? First, data is often fragmented. One study here, another there, and with different methods that cannot be compared. Second, traditional monitoring could be expensive and sometimes too technical for companies. And third, climate change is shifting habitats, pollution is affecting soil and air, and land use change is reducing natural spaces. So that is clear we need for indicators that are reliable, repeatable, and easy to explain. Indicators don't just stay in a scientific report, but can also be used in corporate sustainability strategies and certification frameworks. Our answer to this challenge is the bee biomonitoring network. Today, the network includes more than 500 sites worldwide. Each site follows the same standard protocols, so the data is comparable across countries and over times, and it makes it the first international network for environmental biomonitoring based on pollinators. Pollinators with an S, because we will see together there is not just honeybees. The approach is built on open science, meaning companies contribute to research, scientific research, while also getting variable indicators for themselves. It's collaborative, rigorous, and designed to serve both science and society. And Poland is part of this network through the INSIGNIA project and our partnership with Pszczolarium. How does it work in practice? The process is straightforward. Step 1. Bees leave the hives and forage a large area, about 2 or 3 kilometers around the colony. While foraging, they collect pollen, nectars, and sometimes dust and particles that stick to the bodies. These samples of maybe sometimes pollutant are brought back to the hive by the bees. Step 2, my colleague from Pszczolarium collects samples and sends them to our laboratory. In our lab, we analyze the samples. We use DNA to identify which plants are present or which part of insects. We also test for pesticides, heavy metals, and other pollutants. And step 3, we transform all this raw data into clear KPI that companies can integrate to their environmental report, sustainability dashboard, or certification processes. The INSIGNIA research program forms a scientific basis of our work. INSIGNIA was a research project founded by the European Union with 27 countries participating. It was the largest coordinated project that used bees for biodiversity and pollution monitoring. The project tested was validated protocols for samples collection, but also all the methods for the analysis like DNA and pollutant. The outcome was clear. Bees are effective and low-cost bioindicators that can provide robust and comparable data. Today, we use these methods as the foundation of our biomonitoring services and research, ensuring that every company we work with receive results based on international science standards. What did INSIGNIA teach us? The result was very rich, as you can see, and let's start with biodiversity. So as you can see, in the whole Europe, we have more than 300 apiaries reported with different soil occupation like agricultural, natural, and artificial. Natural means usually urban, so in cities. And with biodiversity, for example, we analyze more than 2,500 samples per year, so which is really huge, the most important studies in the world. And the bees gave us a full pictures of both richness of biodiversity and pollutants. We identify over 1,000 plant species in whole Europe, collected from the DNA analysis, creating one of the most detailed maps of the floral diversity ever produced at this scale. So as you can see, there is different group of countries in Europe, which is normal because we have different climates. So it's we have different clusters, so we can compare each cluster with the others and country between countries. As you can see for Poland, for example, you have 8.3 genera in average per sample, which is in the middle of Europe, which is great. And we have this cluster in the middle in blue, so that you are involved in. One not expected result was if we follow the mean number of genera per soil occupation between agriculture, natural, and artificial, artificial was the most important, where you have the most important number of genera different. So it's just not expected. We thought it was natural areas, but finally it's in artificial, I mean in cities. So why this result is also linked with another result from another European study. It was the same with the pollinators, because in cities we have companies and neighborhood who seed flowers and take care of the flowers during all along the years. I mean, when you have a heat wave, for example, you had water to be sure your plants are in good health. So that helps the bees because we create a huge diversity of flowers, and also we create habitats for pollinators and for flowers. That's why, curiously, we have a better number of genera in artificial than natural agricultural sites. Let's now move on to another type of pollutant. It's microplastics. So microplastic is very interesting, and what you can see here is a real microplastic bring back from the bees to the hives. So we use a special frame. Kamil will present you that. So as you can see, you have different colors, different shape, and it's possible to analyze all the things. Just to a brief summary of the result. What we have on two maps, you have the fibers and the fragment and films on the other side. As you can see, hold the point. So in blue, yellow, and red, you have the amount of microplastics. So in red, you have the hotspots of microplastics. So this kind of pollutant is worldwide, in Europe especially. So it was not expected. The point is there is no statistical differences between cities and natural site. So we expect to have more microplastic in cities instead of natural site, but it's not the case. It's similar. That means microplastics, unfortunately, are everywhere. Sometimes in some site which is not expected. For example, look at the north of Europe. In Sweden and also in Finland, you have hotspots in the middle of the forest in very natural countries. So it's very curious. So we have to have a better understanding of the situation. Now let's switch to another result with pesticides. So we analyze more than 6,000 HAPA strips, which is a tool that we use to analyze pesticides. So we collected more than close to 18,000 data, 18,000 different pesticides and location. So it's really huge. It's the biggest study in Europe for pesticides using bees. Unfortunately, there is no apiary in whole EU, and even if in natural site, without pesticide at all. So even if the environment is very natural, you always have pesticides, which is not expected. There is a little bit more pesticide into agricultural side, which was normal, but we also have pesticide into natural side. So it's not great for the environment, and because we know the presence of pesticides is linked with insect decrease and pollinator decrease. So that's why we follow these kind of indicators. Okay, so from this EU science project, we built a toolbox with KPIs. On the air and pollution side, we measure heavy metals, pesticides, microplastic, we talk about it, but also pollutants like VOCs and PAH. We see pollutants from the air. PAH are produced from the combustion, so that means from the car, and especially this pollutant comes from cities. Or PFAS. PFAS, you maybe heard about it. It's called also eternal pollutants. These indicators show environmental risk and pollution pressure on biodiversity. On the biodiversity side, we measure thanks to eDNA in honey, or with bumblebee or osmia bee bread. We can use different pollinators. So the indicators are species richness, which is how many different species do we have found in the environment. Diversity indexes, which is the same index, but we had the abundance. So how many flowers we have of this species. The functional diversity also include the shape of the flowers, because some of them are more interesting for butterfly or something else. And we also can detect threatened or invasive species. Invasive species is very important because then we know that we have an impact, a direct impact on the biodiversity. These indicators show ecosystem health and recovery potential. It is also possible to have biodiversity KPIs thanks to geospatial data, but this is another story. We can talk about it later. So together, these KPIs give company a balanced pictures, not only where the risks are, but also where positive biodiversity value is created. And we will talk about it in some example. One of the most important aspects is how these KPIs link to international certifications. For example, in LEED, companies can gain 5 points under innovation and pollinators-friendly initiative, like the use of eDNA, which is very innovative, and participatory research program. So at the end, for example, we use your data, if you agree with, to publish some scientific article and try to understand what's happened with the decrease of the biodiversity. In BREEAM, biodiversity action and metrics can bring between 6 to 10 points in land use and ecology. In this case, habitat developments, when, for example, with Kamil, you could have some nests for bumblebees and also for osmia and native bees. So when you use multiple pollinators, it's really a plus for this for the BREEAM certification. And under CSRD and TNFD in Europe, CSRD companies have now a legal obligation to report on biodiversity impact, risk, and opportunities. So our KPIs are designed to fit directly into these frameworks, making them not just scientifically strong, but also strategically variables for certification, compliance, and investor confidence. So let's take a real example for heavy industry. Large companies, because it's a group of companies operating in Dunkirk, in the north of France, port, and they wanted to understand the environmental impact of air emission, so usually it's PAH and heavy metals, on local biodiversity. So with biomonitoring, we collected hundreds of real-world data points on pollutants and local plants biodiversity. As you can see, we follow pesticides because companies are surrounding by agriculture, so they want to know the impact on the agriculture on their site. And they also follow PAH and heavy metals, which is both a pollutant produced by those companies. On the biodiversity side, we use eDNA in honey to follow, as we discussed just before, species richness, diversity index, threatened species, invasive species, etc. So the result was transformed into a full impact report, which was shared to stakeholders and regulators. The outcome was not only greater transparency, but also improved trust. The company could show how it was measured, understanding, and managed its impact on nature. So we have the link with the beekeepers. We discussed with them directly, and also with the neighborhood because they were worried about the situation. So it's very clear for the companies that they could help to understand for the stakeholders. As you can see, on the right, we follow, this is real data. So we follow, for example, the decrease of the PAH since 6 years, I think, right now. So they can have the proof for the stakeholders that they have a decrease of this pollutant. So that means an increase of the air quality thanks to all the actions that are put in place. Now, for the second example, comes from finance. A major bank, so JP Morgan in New York City, wanted biodiversity indicators for 2 reasons: compliance with regarding standards, so in their case it was CSRD, and employee engagement, which was very important for them. We implemented biodiversity monitoring, so beehives and rooftops using DNA from honey, and the result became part of the annual biodiversity report. The bank also used the result to create a wellness program for employees who could also show how their own workplace environment connected to nature. This double benefits reporting and engagement made the project a real success. Now, another example from renewable energy sectors, a solar farm in France was built in a deforested area. They were concerned about habitat losses, of course. We monitor pollinators and floral biodiversity after the construction in comparison with the control point, so 2 sites. Within just 1 year, our data show no statistical differences between the study site with a solar panel and the control point, which was in a similar soil occupation. And the biodiversity data are in the same benchmark values in green. So as you can see, for the biodiversity index at 0.26, they are in the green benchmark values. And green benchmark values, that means in comparable site in the rest of the country and in the same soil occupation, I mean, it's a forest with agricultural areas, the level of this biodiversity index is in the middle, so that means it's comparable. This result demonstrated ecological responsibility and showed that renewable energy project can successfully integrate biodiversity recovery and measured correctly, because we have an evolution. The evolution is positive. That means years after years, we have an increase of the level of biodiversity because they have created open spaces. So they have some new flowers, and these new flowers create new resources for pollinators. Another point we talk about monitoring: honeybees are the most widely used pests. They are easy to manage, they forage over large areas, they provide lots of data. But bees are not the only pollinators. Other species like bumblebees or solitary bees have different foraging behavior. In this case, the clients want to have more accurate data and be involved in science research. So by including other pollinators, in this case it was bumblebees, they get more complete pictures of the environment. Honeybees can tell us what is happening in the borders landscape, and while bumblebees give us more local and specific information. To test this complementarity, we carried out research comparing the foraging of bees and bumblebees at the same time on this previous study site. So we used DNA beta barcoding as usual. In this study, we applied 2 different DNA primers. One is tRNL and the other ITS2. That's why you have 2 sets of results. The findings are shown in the diagram. On one side, the plant detected by honeybee in blue, on the other, the plant detected by the bumblebee in green. And in the middle, the overlap, the species visited by both pollinators. Honeybees and bumblebees share about 5 to 35% of pests. As you can see, it shows clearly that the 2 pollinators do not forage the same way. They are not in competition, they are complementary. Together, they provide a richer and more accurate picture of floral biodiversity. The conclusion is important. If we only monitor with honeybees, we capture just a part of the environment. But if we include bumblebees, we gain a broader and more robust data set. And we can ever detect rare or threatened plants that honeybees alone might miss. This research was published in the journal Insect of Science just yesterday, that's right, giving strong evidence and credibility to our approach. So this result is really great because we have a better view of the floral biodiversity, and you can see the overlap is really low. So that means they can work together on the same plants, and there is no risk of competition in this case. On this slide, you can see the result of our 2024 annual research report on complementary pollinators. We also tested honeybees, bumblebees, and mason bees as environmental indicators on rooftop, the three of us, in Helsinki, in Finland. The diagrams show how much overlap and how many differences exist between the diets. Honeybees detected some plants, bumblebee detected others, and mason bees detected more unique species. So it's very curious because in this case, as you can see, we have 33 different species detected by mason bees instead of just 9 and 3 by the two of us. And when we combine all of them, we see that each pollinator had new informations. They are not in competition in this case, scientifically, they are complementary. And below, you can see the life cycle. Honeybees are active all the years and give us a long-term view, which is very important because we want to see follow the floral biodiversity during all along the years. Bumblebees are very active in spring and in summer, adding strong seasonal details. And mason bees are very active early in spring, give us even sharper pictures of floral resources at the start of the season. So it's very complementary, but if you want to have a whole view of the season, honeybees are the only one who can help us to do that. By combining all these three pollinators, we can monitor biodiversity more completely. Honeybees give us continually, bumblebee and mason bees bring in seasonal precision and together allow us to describe the landscape with much more greater accuracy. So to conclude, the message is simple: join the network, measure your impact and protect biodiversity, and lead the way. Bee biomonitoring is practical, scientifically robust, and directly variable for business. It turns pollinators into environmental data collectors and transforms that data into KPIs that support certification, compliance, and reputation. Thank you very much for your attention, and I warmly invite you to join this journey with us here in Poland and across the world.
Yeah, thank you, Ben, for your presentation. It was very, very interesting. And if anybody has a question to Ben, just write it in our chat box. And at the end of our meeting, there will be a Q&A section. And now we go to Kamil. Kamil, please.
Yes, I'm here.
Okay. So now I'm...
Just tell me when I start, or should I now?
Yes, you can start now.
Okay, so welcome everybody to our Warsaw workshop of Pszczelarium, which is basically a place where we service bees from, where we take care of the bees around Warsaw, inside Warsaw, but also on the countryside around. And we also coordinate activities around bees in more than 40 locations in Poland. So we use like a standard modern hives, as you can see here. And I like to think of them as really a data source and research stations, actually, where we collect data from, because not only, of course, it's the passion, but we've been collecting data from the very beginning on what was the main forage of the bees in Warsaw, as I previously, from the very beginning of my childhood almost, I've been dealing with traditional beekeeping. So the data we collected from already for 10 years we've been collecting have showed us that the main forage of the bees inside the city somehow is different than the bees from outside the city, from the countryside, as there are mainly crops there, agricultural crops. But here in Warsaw, we are basing on trees like linden, and it's the most abundant source of nectar, linden tree, but also horse chestnuts. So we are able to collect horse chestnut honey, and maple nectar, which is the earliest actually crop the bees would substantial crop the bees would have. And this is complemented also by other species of plants, like, for example, ivy, winobluszcz, or hawthorn, which is głuk in Polish, or even even rapeseed. We have actually collected rapeseed from the hives inside the city, because the bees would fly to the outskirts when they tracked the fields with rapeseed. So there are many points that bees visit, but the main sources are basically trees. So we've been conducting a lot of research, and this is like a folder of some part of our research, and you can see a table that we basically had visual examination of pollen done so far before we met with Ben. So this was a magnification of honey sample and identifying visually the pollen types and grains that could be associated to the types, to the families, sometimes to the species level of plants and what they collected. So I'll put that aside and let me show you that the bees that are used for biodiversity or biomonitoring analysis are the same bees, right? This is the same hive, and what we collect is actually for the biodiversity. We collect the sample of their products, nothing more actually. So what you see here is a honeycomb, and what we would get to a sampling tool, which is a sterile tube, is a part of the honeycomb, and this would be examined by Apilab and by doing the DNA tests, right? So this is much more advanced method, basing not on a visual, let's say, identification by a human, but made in the very sensitive laboratory testing and procedures, just by examining the products of bees. So honey would give us most reliable measures on biodiversity, so what the bees would collect nectar from, and also other sources of pollen in their environment. And look here, this is basically what we would examine for this substance, which is propolis, right? And we would examine it for potential pollutants on so-called heavy metals. So basically, let's say it's the some specific elements, right? Chemical elements. Basically, we would focus on heavy metals by examining propolis. So we would also collect propolis. And I want to underline that this laboratory DNA testing is so so detailed that it does not alter the quality of honey. I mean, potential pollutants that are detected are not to the level of potentially polluting the honey or the other bee products, like, for example, bee bread. And what our clients get actually is the honey from their hives, and it's raw honey, which I define as honey that was not filtered and not heated to a temperature above the safety, what is safety for honey. So that's why you can actually see a small grains, specks of wax or bee bread inside the jar. And please don't be somewhat afraid of having honey like this. On the contrary, it says that the honey is of good quality and raw, right? And medical treatments have proved that only raw honey, not processed honey, can benefit the people that are eating this honey. So to sum up, the honeybee can be an excellent source, as thousands of worker bees will fly out almost every day for a forage to look for nectar, pollen, and they would collect millions of data over the season. So starting from the very early days of spring to the last warm days of autumn even, right? And they would cover a big area of, for example, like 15, 20 square kilometers around the apiary. right? And they would allow us to also measure the sorry, the pollutants in the surrounding, right? But not only we work with honeybees, we work with bumblebees as well. And this is the nest of the bumblebees we got ready for testing this year, and we do that test in Warsaw and Łódź currently. So we have like typical nest, and the bumblebees here are making a small colony. This is not like thousands of bees. This is only like maybe not more than 200, maximum 300 of bees. And they have really small scale, as Ben said. So potentially they would fly only a couple of 100 meters from outside of their nest. Look, but their benefit of using bumblebees is that they would pollinate much broader scope of flowers than honeybees. So basically, their food don't actually overlap maximum a couple of or a dozen percentage. Oh, I got stung by a bumblebee, right? Anyway, this is a nest of the bumblebee. So we would service only at the very beginning or at the very end the bumblebee's nest, and they would be basically without any maintenance left. And we would collect the data also to such a probe with a small sterile tool. So we would basically open, more than I opened now, we would open the nest and have a sample of nectar. They produce on an actually daily basis because they don't actually store nectar in big amounts just for basic current use. They would store it. So I close the bumblebee's nest, and let me just drive your attention to a solitary bee's house, where you can see how many tubes are sealed. This means every sealed tube is a tube where a solitary bee, mostly probably mason bee, maybe in some places we would see a couple of leafcutter bees, but mason bees mostly, would collect pollen and bring this pollen to a small chamber, collect this pollen for a couple of days, lay an egg, and close the chamber and start the next chamber next to the previous one. So we would also open the tube, and this is an example. We can see here that there was a nesting and the remains of pollen in the tube. It's the cross section basically. And this is an old design of the honey house, not the honey house, but the solitary bee's house, which you may actually find in many places. Very basic, and it's better to service that once every year. We do that, so we collect the cocoons and we put them into a refrigerator so that the parasites don't get proliferated too much, and the cocoons have then more chances to overwinter. Then during the spring we take them out again and put outside so that the solitary bees can hatch. This is like very simple to collect, but it gives really a fraction of the plants that would be blossoming throughout the of the season would be visible in the results, right? This is now not active, as all the bees, so the solitary bees, were active here mostly in May and early June. And servicing usually takes place in the autumn, right? So the new design of our bee hotel is this. So this we put in a couple of places already in Poland. a couple in Warsaw and southern Poland as well. And our goal is to have as many different, habitats for the bees as possible. We will refine this design, and it's being refined actually all the time. But we will refine it also to allow more ground nesting bees to put their nests in. Actually, now you have some places for bumblebee's nest and butterfly nest and leafcutter and mason bees mostly. You can actually see how, and we treat it with really much of detail. To really detail, you can see that the edges of the holes are done neatly so that they are not fried, so that they're smooth, so that they don't actually, there's no risk that they would somehow make the bee body altered with specks of wood. So we try to make it as good as possible, and this is also what I'm proud of. And here, not last but not least, on the balcony, what I wanted to show you is the watering station. Maybe not everybody can imagine that the bees would collect also water, and this is basically the poultry waterer, but we use it as a base for some innovations, and we put a couple of innovations to it, basically to prevent the algae growth. Splitting water by birds, or obviously insects drowning. So we put a couple of changes to that design, and it's been quite successful actually, and properly done. It actually allows not to be maintained for even more than a month. Once filled, more than a month of being a watering station, and sometimes bees would use it, of course, when they have a water source in a radius for, let's say, within 200 meters. They would probably prefer natural water sources, obviously. But it's our standard that we use watering station wherever we think the water would not be available inside this radius, or we would also use it when we have bees on the rooftops higher than 4th, 5th floor. So this is our standard. And also, I have not mentioned yet, but what you can see here around us is the green park actually, and I must say we also should take care, and we are taking care of what grows, and on the very, very close to our workshop, there is a meadow we've done. There are some plants we've planted, and we also can advise and provide our clients with bee-friendly plants. And sometimes, usually, even a small change in the habit of mowing the grass would be even very beneficial for the bees. So this may not be even involved in any kind of substantial investment, just changing the habits and changing the contracts, the way it's contracted for gardening, let's say, companies, right? So now I will invite you inside, because last but not least, I want to show you the educational room, because where the bees are, usually the education is, right? So from the very beginning, we've done a lot of bee courses. We started from the beekeeping courses, but currently we have also wild bees and native bees specialists aboard, and we provide courses for and events, workshops for children, for companies, for institutions, and we actually can do the workshops here in our workshop, or we can travel all around Poland, as sometimes happens. We have many gears and stuff to provide a good, measurable knowledge. So to sum up, having bees or honeybees, bumblebees, or solitary bees together with additional services can basically, as Ben said, earn BRIAM points, or not only be something nice to have, if you wish, but also, for example, biodiversity measures made by BRIAM can benefit from examining the honey from the hive, tracing the plants that the bees would have in the range, and then we can measure, analyze the data, and, for example, plant some other plants that would be friendly and beneficial for the bees and increase potentially biodiversity. Or, for example, as we've done in Grodzisk Mazowiecki, we can have ground nesting sites done by us, which is basically called sandarium. And this is also like a place where if the bees are in the vicinity of the spot, they can make holes, and ground nesting bees will be there to have a place to live, right? The other example is for air quality or water and soil quality measures by BRIAM, where basically from mostly honeybees we can get samples of these pollutants, pesticides, heavy metals, or even microplastic, right? So then we can get this data, analyze it, and even make guesses up to where the source may be, especially when we have some trends, and we do this examination in more than one season, and that would be also beneficial. So with this powerful tool of biomonitoring and bees on site, I think we can have really good analysis, good data as input for conscious decisions and to get measurable results. And that's what I wanted to leave you with. Thank you.
Kamil, let me turn on my camera. Thank you very much for your presentation, and that you show us the bees and the bumblebees. And now, if anybody has some question, just write it in the comment section, and there is time for this. So I think we have some.
Were there any questions?
Yes, there is one question.
Just let me check.
I just need to. Yes. Oh, yes. Q&A. Yes. Okay. And now. So I can't show it on the screen, but there is a question: how often do you use this method in a year? So how many times in a year do you?
Maybe I can try to answer. Maybe Ben would get some more maybe points if necessary. So it depends on the goals and needs that the client has. We can sample only once, and it will give us only partial data for part time of the season, right? So the more times we sample, the better. Let's say the better, the wider the results we may have.
Mm-hmm.
Usually 4 times a year is quite good for having taken all the major sources of pollen in the environment as per honeybee. So 1 to 4, I would answer. Maybe Ben, you can add something to that.
Yeah, if I can complete, absolutely. There's a scientific article we just published. We have the curve, and we explain, so if you just analyze one time, so you have maybe just 20% of the whole biodiversity. You just have an idea. So if you want to do the job correctly, usually we analyze 3 times, 4 times a year, which is what we do usually to have an annual survey of the for biodiversity.
Okay, Thank you very much for that answer, both of you. And for now, we don't have any more questions. So if anybody think later about it and has questions, just let email to Kamil or to Ben or to me, and we connect you with them. So thank you everybody for joining us today for this meeting, and thank you our experts for their presentation. And of course, this meeting is recorded, so if anybody join us later, there is no problem, because there will be this on our YouTube, so you can check it later. Okay, so thank you once again, everybody, and wish you the best of the rest of the day.
Thank you.
Bye. Bye-bye.
Bye.